Saxon's Calculus Review Lesson A, the real numbers, and then fundamental concept review, starting on page 1. So the first thing they do is a review of the different category names for numbers. So you should have hopefully memorized that a capital N is standing for the natural numbers, or what we call the counting numbers, or the positive integers. And it does not include 0, it's 1, 2, and forever. Then the Z is for your integers. So it includes everything that we had here in the naturals, the 1, 2, 3. It includes the 0 and it includes the negative. So here I didn't say plus 0. We could include the plus 0 there in that list to be precise. But Z is for integers. And then Q is for your rational numbers. And I see that I did not write that there. So rational numbers. So it is everything that was your positives, your negatives, your zeros, so everything in your integers, and then it includes your fractions and decimals that either end or repeat, and that's the letter Q. Then we have irrational numbers. Their fractions do not end or repeat. There is no special symbol for irrational numbers. And some examples of those are pi, which we memorized at 3.14 and stopped, but calculators, or computers rather, have continued to analyze and never found a repeating pattern, and it's still ongoing. The same thing with E. We've memorized it at like 2.7, but it continues on and on and on. If you do the square or the cubed root of 13 on your calculator, you will see that it does not end or see a repeating pattern. And then we have our capital R, which in our book typically has the 2 straight lines at the beginning for the R, and it's your real numbers, and it's basically everything. It's the rationals, the irrationals, the integers, the natural numbers. And so they remind you about this in set notation, where the natural numbers are an element of, or in this case, subset of the integers. Integers are a subset of the rational numbers, and rational numbers are a subset of the reals. Now they shift gears from reminding you about the names of all the different kinds of numbers, and they go into graphing a dot on a number line, so that's a coordinate point. So 3 graphs a dot at, so here's 0, so 1, 2, 3, we've graphed that dot. 1 plus root 2, if you punch it on your calculator, the root 2 is 1 point something, so it's 2 point something. It's much closer to the 2 than it is the 3, so you put a dot close to the 2 and label it 1 plus root 2. Negative 2.5, of course, graphs into the negatives at 2.5 backwards, and then you label that as your point. That is page 1. Now flipping to page 2, I left a little space here because I wanted to talk about the box. And anytime we see a box, if you were with us in trig, you know that that is very important information, a formula of some kind that you need. So this first one is order properties, and it says if you have 3 numbers represented by the x, y, and z, then in 1, the first rule is that you have a trichotomy, meaning the x is either going to be less than the y, the x is going to equal the y, or the x is going to be greater than the y. One of those 3 things has to be true. The second rule is transitivity, and it basically says that if x is less than y, and y is less than z, what conclusion can you draw? X will be less than z, and that's transitivity. Number 3 is addition. If you have x is less than y, you can add the same concept to both sides, z, so we'll say x plus z, and if that's true, it will remain less than y plus that same z, because this number is always going to be smaller and you're adding the same amount. The fourth one is multiplication. If z is positive and x is less than y, if you are multiplying that, then xz has to be less than y, z, and that only occurs when z is positive and the x is less than y. If z is negative and x is less than y, then that's going to flip to xz is greater than yz if you're dealing with the negative. And then we move on to the second big box, which is, I do try to highlight the bolded words, and in between the two boxes, they talk about the word field, and it's saying that real numbers constitute a field or a group, a set of information. And so the field properties is the title for this box. And you should recognize commutative, associative, distributive, identity, maybe not so much inverse in this list of others, but it is included in the field properties. So commutative says so I try to link it to an English word that will help you recognize what it should be. Commutative matching with community. So I live in the same community, whether I live in the first house or the second house, I still am within that community. So that's telling me that the order does not matter. So I can have x plus y is the same as y plus x. It works the same for multiplies, so xy is the same as yx, and it's the same for commutative and associative. You've got a positive one and a multiply one. Associative is who you associate with. It's who you're linked with. So it involves some sort of a parenthesis. So if you have x plus y plus z, and in this first one, those two are linked, it is the same as linking these two and then adding the x, because we know when we solve what's in parentheses first. You get the same answer whether you put these two together first and then add the z, or put these two together and then add the x, same answer. And then the same thing in the multiply. That's going to be a little harder to cram in here, but x, y, z, linking these two is the same as linking these two in the multiply. Distributive is where we have x multiplying with, we'll say, y plus z. When you distribute, you take the outer number and multiply it with each piece. So that gives you xy plus xz. And you have done distributive for quite some time. I don't think that anyone's going to feel like that's a brand new concept. And then our identity is, what do we do with something when we add it that keeps it being itself? It's its own identity. Well, when you add a 0. When you multiply, what do you multiply something by to keep it itself? A 1. And those are the identity properties. Then we have our inverse. So so the reciprocal actually applies to the multiply part, but we're asking ourselves, x plus what would equal the 0, because that was the identity number here. So that would be negative x. So its inverse is when I change its sign. For multiply, x times what would give me, and the identity number is 1. So that's where I turn it, I reciprocal it, that's why that word was there, to 1 over x, but I'm not changing the sign on it. Okay, so now that we've reviewed all of those, they change gears to part B, and they say, let's start reviewing the problems that we did in trig that we learned throughout the book on how we manipulate and solve things algebraically. So the first example I have written here, example 1, and when it's all letters, remember that it has to give you what you're solving for. So we're solving for the letter C. Now that I know what I need to look for, the first thing I want to do is fix inside my parenthesis like you would with algebra. So y equals v, and this needs a common denominator to go together, which would be xmc. This one has the x, it's missing the m and the c, so you need the m and the c attached with the a part here. Plus, this one has the MC, it's missing the x, so the x needs to be attached there. So when I write it as one big fraction, that's bx. Then, according to algebra, I need to distribute this v into this box. So we get VAMC plus VBX all over the xmc. Now we need to remove the denominator to the other side. So it's multiplying over to here. So we're getting yxmc equals VAMC plus VBX. Now that I'm here, this is where it's critical that I know what I'm solving for. So everywhere that has a C, which is these two terms, they need to be together on one side. So we're going to choose to move this one over. YXMC minus VAMC now equals the left VBX that I didn't touch. Pull the C out, and that leaves the YXM minus VAM equals VBX, no change. And then to get the C alone, we divide by this parenthesis to remove it. So our numerator is the VBX and the denominator YXM minus VAM, and we've solved for the C that they asked for. Now moving, let me check that answer real fast, just make sure there's no problems. Now they have the order of the letters rearranged. That does not matter, especially this one. They have it as MVA, but it means the same thing. So if your order is different than the answer key may be, it's all right. Example 2 is in two parts, an A and a B. And we are going to start with the A one. Again, we have a series of letters, and I have fraction over fraction over fraction. So the key to this is start at the lowest one and work your way up. So the common denominator for this would be D. And since this is a 1, if I make this D, then the top becomes a D. So we're going to rewrite our X over A plus M over, and then let's simplify this to one fraction D plus C all over the D. Now when you have a fraction over another fraction, and this is implied as M over 1 in its fraction form, you are flipping, because fractions mean divide, so when you divide, you flip a fraction and change it to multiply. So the lower one is the one that flips, and then it multiplies with the M over 1. So this gives us, rewriting X over A plus, so then M times D is MD. 1 doesn't change anything, so this remains D plus C. Now we're going to repeat our steps. This needs a common denominator in order to be added together, so X over. The common denominator is D plus C, so this one needs the D plus C, which means the D plus C has to multiply with the top as well. So that's going to distribute A times D plus A times C plus, and this is now had the common denominator, so plus the MD all over that same denominator, D plus C. So again, this X in the top implies X over 1. The bottom one's going to flip when we multiply it, so D plus C has gone to the numerator, and repeating AD plus AC plus MD, and then put all that together. This is also a distribute because anytime I've got a plus or a minus, I know I have a unit. So XD plus XC all over, and the 1 thankfully doesn't make any changes, so AD plus AC plus MD. Now let me check. They did not distribute their X in their final answer. That's okay, nor did they distribute the A, but this is still the acceptable answer. All right, yeah, their next part is the B part that was being solved for. So now this is part B. I have fractions being added together, fractions being added together. So we're going to start with a common denominator up here, which should be X squared. This one doesn't need a change, but this one needs another X, which means we're going to put another X with the numerator. A plus BX all over X squared. Do the same thing here. The common denominator will be, now this one's X squared and X, so X squared is the higher exponent value, and we still need the C. So this one has the X squared, it's lost the C, so it needs a C added with the numerator. This one has one X, but needs another X to be X squared, and it has the C. Then CM plus KX all over that. So fraction divided by fraction, flip and multiply. I'm going to have to rewrite that since there's no space there. Over X squared times X squared over C, with CM plus KX. Now, I see an x squared and an x squared, one in the top, one in the bottom. I can cancel these because they're not attached with a plus or a minus. These can't be separated. They're units. They're stuck together. So this C, this time I'm not going to distribute it. I'm just going to write C multiplying with A plus BX over top of, and there's nothing left to change this one, so CM plus KX. And I usually on these also check to make sure that there is no letter in all four of the terms that's the same. This one's CA, CBX. This one has a CM, but this one doesn't have a C, so I don't see there's not an X with everybody and so on. So I just do a quick mental check to make sure there's no extra reducing to do in there. All right, example 3 is 4 plus root 2 over 3 minus 2 root 2. Now, hopefully you remember from trig that you are not allowed to have a root in the denominator. So we need to multiply it by something that is the equivalent of 1, because multiplying by a 1 does not change its value. And we also want to remove the root from the bottom. So the way we do that is we change the middle sign, and we do that same thing top and bottom. And hopefully that rule you have not forgotten. So now we're going to have to distribute. And because this has a plus and this has a plus, they're units, they're stuck together. And so we're going to have to either FOIL or distribute, or whichever method you are preferring. So the first number times the first number, 4 times 3 gives 12. Then 4 times 2 root 2 is 8 root 2. Now the whole numbers in front multiply, but the root 2 is like an X or a Y or a variable it's kind of carrying with. Root 2 times 3 is 3 root 2. And then root 2 times 2 root 2. Now the root 2 times root 2 is basically the square root of 4, which is 2. So what we say is we shortcut this mentally, and if it's the same thing inside, the doubling of it kills off the square root and just leaves the 2. So what we have here is this being a 2 multiplying with the outer 2, which was already there, so this term becomes a 4. Now, when I do the same thing with the bottom, 3 times 3 is 9. I will write it in this case, but as I continue, if you were with me in trig last year, you know that I know automatically, because I did the change in sign, it's forcing it to cancel the middle term, and so in the future I won't even bother to write the middle term. But just to prove to you how this works, 3 times the 2 is positive 6 root 2. Negative 2 root 2 with the 3 is negative 6 root 2, and then finally negative times positive is a negative. 2 times 2 is a 4, and the root 2 is another 2, so 4 times 2 is 8. All right, so now up here in the numerator, the like terms are the 12 and the 4 and the root 2's. So 12 plus 4, 16, 8 plus 3, 11, root 2 carrying with. Then the 9, oh, wait a minute, 9 and 8 are like terms. So 9 minus 8 is 1. And then this positive root 6, negative root 2, goodness, saying that backwards, because they're opposites inside, they're going to cancel off. So the denominator only keeps the 1. Well, if my denominator is 1, then I certainly don't need it. So 16 plus 11 root 2 is the answer that will be boxed. All right, because it is the same similar concept, I'm going to go ahead and do example 4. So it gives us 3 root 3 halves minus 4 root 2 thirds minus root 24. So the first thing is to separate these into their individual roots rather than a fraction inside a square root. So 3 root 3 over root 2 minus 4 root 2 over root 3. And then this 24, I want to see if I can simplify it. So I'm looking for what numbers multiply to give me 24. Now I may see it differently than you see it. I'm gonna do 2's. You might do 6 going into that. It doesn't really matter. We should all end up in the same place. So 2 times 12. 12 splits into 2 and 6 splits into 2 and 3. Everywhere I have a set of numbers, that root 2 times root 2 is again root 4, which is 2. So a set pulls out to the outside as a single number. So this is minus 2 from here pulling out. And then these numbers didn't have mates. So they're left to multiply back together and stay stuck in the square root. So that's square root of 6. Now I can't keep roots in these denominators. So we're going to multiply by a 1, something that equals 1, so keep it the same number, top and bottom, root 2 over root 2. This one is going to multiply by root 3 over root 3. So now we have 3. Root 3 times root 2 is root 6, all over root 2 times root 2 is 2, minus the 4 stays here. Root 2 times root 3 is root 6 over root 3 times root 3 is 3. And then we have still our minus 2 root 6. Now, before I can go any further, they must have a common denominator of 6. So when this one goes to a 6, this multiplied by 3 and changes it to 9. This one multiplied by 2, so this changes to an 8. This multiplied by, is missing the whole thing, 6. 6 times 2 makes this one 12. Now they all have the same root 6, so they're all like terms. 9 minus 8 is 1 root 6. 1 minus 12 is negative 11 root 6 all over 6. And can I reduce the 11 and the 6? No, so this is as far as it can go. Now the lesson continues with examples 6 through 10. I'm going to stop the video here and do those examples in another one because in the classroom I'm going to be teaching this in 2 separate sections.